You ever pause to wonder if there could be water on the moon? Quite a thought, isn't it? Our nearest celestial neighbor, always there, silently circling us in the night sky. Its surface, a barren, desolate expanse of gray, pockmarked by countless craters. It's a place that, at first glance, seems as dry and lifeless as can be. But is it really? Imagine, beneath that dusty, moon rock-strewn landscape, a resource so precious, so vital for the survival and expansion of human life in space. Yes, we're talking about water. But how could water exist on such a parched, inhospitable place? It contradicts everything we've been taught, everything we've seen with our own eyes. Yet, the evidence is mounting, and the scientific community is buzzing with excitement. So, strap in, fellow space enthusiasts. We're about to embark on a voyage of discovery, a lunar journey like no other. Join us as we unravel the fascinating journey of the discovery of water on the moon. The journey begins in the late 1960s, a time of space exploration and lunar missions. This was an era of firsts, a time when humanity reached out to touch the face of the moon. It was an era of heroes and pioneers, men and women who dared to dream and ventured into the unknown. The Apollo missions were the flagship of this era, a series of manned lunar missions undertaken by NASA, the United States Space Agency. These missions aimed to fulfill President Kennedy's bold challenge to land a man on the moon and return him safely to Earth before the end of the decade. But beyond this grand ambition, the Apollo missions had another objective: to bring back samples of lunar rock and soil. These samples would provide invaluable insights into the moon's history and composition, and possibly even hint at the existence of something that had been thought impossible: water on the moon. When the Apollo astronauts returned from their missions, they brought with them over 800 pounds of lunar rock and soil. These samples were like time capsules, preserving billions of years of lunar history. As scientists began to study these samples, they found something unexpected. Some of the rocks contained tiny amounts of a substance called hydroxyl, a molecule made up of one hydrogen atom and one oxygen atom. This was intriguing because hydroxyl is often associated with water. But was it really water, or just a similar compound? The evidence was tantalizing but not conclusive. It was the first clue, a hint that there might be more to the moon than meets the eye. These discoveries didn't prove the existence of water on the moon, but they did raise intriguing questions. If there was water on the moon, where did it come from? How much was there? And most importantly, what could this mean for the future of space exploration? These first clues sparked a curiosity that launched a new wave of lunar exploration. But as we would soon discover, finding water on the moon would prove to be a journey full of surprises, controversy, and scientific breakthroughs. But that, dear listeners, is a story for another time. As the 2000s dawned, so did a new era of lunar exploration. The moon, our closest celestial neighbor, was about to unveil more of its secrets. The early part of the decade saw a flurry of lunar missions. The Lunar Reconnaissance Orbiter, fondly known as LRO, launched by NASA, was one of the pioneers. This spacecraft was equipped with a suite of sophisticated instruments, one of which was designed to look for the telltale signs of water, and it didn't disappoint. LRO's spectrometer detected signals consistent with water molecules scattered across the lunar surface. Around the same time, India's Chandrayaan-1 was making waves. Its Moon Mineralogy Mapper, or OM3, detected signatures that scientists interpreted as water ice in the moon's polar regions. This was a groundbreaking discovery, as it suggested that water might not only exist on the moon, but could also be in a form that's potentially useful for future lunar explorers. But with confirmation came controversy. Some scientists were skeptical. They questioned the interpretation of the data, arguing that the signals could be due to other phenomena, such as the presence of hydroxyl ions, a molecule that's similar to water but not quite the same. The debate was intense, with researchers on both sides presenting compelling arguments. Then, there were those who questioned the practicality of these findings. Even if there was water on the moon, they argued, would it be accessible? And could it really be used to support future lunar missions? These were valid questions that reminded us of the challenges that lay ahead. But despite the skepticism and controversy, The confirmation of water on the moon was a momentous discovery. It wasn't just about finding a few molecules scattered across lunar soil. It was about changing our understanding of the moon, and by extension, our place in the cosmos. It was about redefining what's possible and opening up new avenues for exploration and discovery. Despite the controversy, these findings opened up a world of possibilities. We were no longer just looking at the moon, we were seeing it in a whole new light. Fast forward to the present day, and the search for lunar water continues. With the latest advancements in technology, we're not only reaching new heights, we're also diving deeper into the moon's hidden secrets. One can't help but marvel at the recent missions that have transformed our understanding of the moon. The Lunar Reconnaissance Orbiter, for example, has been orbiting our celestial neighbor since 2009, sending back valuable data about the moon's surface. This data has provided evidence for the presence of water ice in the permanently shadowed regions of lunar craters. And then there's the Chandrayaan-1, India's first lunar probe. Launched in 2008, this mission detected water molecules spread across the lunar surface. More recently, the Chandrayaan-2 mission aimed to further investigate the abundance of water on the moon. Not to be left behind, China's Chang'e 4 mission also made a significant contribution. The Yutu-2 rover, as part of this mission, has been exploring the far side of the moon, providing us with invaluable insights into the moon's geological history and potential water reserves. In the last few years, missions have become increasingly sophisticated. NASA's Artemis program plans to land the first woman and the next man on the moon by the mid-2020s. One of its goals is to investigate the water ice near the moon's south pole, which could be a game-changer for future human missions. Meanwhile, the European Space Agency has its sights set on the moon's polar regions with the upcoming Lunar Pathfinder mission. This mission aims to provide a detailed map of the moon's water ice distribution, which could help pave the way for future human habitation. These missions and discoveries have not only deepened our knowledge about the moon, but also opened up exciting possibilities for the future. The presence of water on the moon could transform lunar exploration, making the moon a potential outpost for further space travel. These discoveries bring us one step closer to unraveling the moon's watery mystery. So, what do these discoveries mean for the future of lunar exploration? Well, let's imagine for a moment, the discovery of lunar water could be a game-changer for the future of space travel. It's not just about finding a new source of drinking water, though that's certainly important. It's about so much more. For one, water can be broken down into hydrogen and oxygen. Hydrogen can be used as rocket fuel, and oxygen, of course, is vital for astronauts to breathe. Having a ready supply of both on the moon could make it a kind of pit stop for missions venturing further into the solar system, like Mars or even beyond. Even more fascinating is the potential for lunar habitation. If we can figure out how to extract and purify this water, it could support a permanent human presence on the moon. This isn't just science fiction anymore. It's a very real possibility that scientists and space agencies around the world are actively investigating. But it's not just about practicalities. There's a deeper, more philosophical implication to these discoveries. For centuries, the moon has been seen as a barren, lifeless rock. Finding water there challenges this perception. It makes the moon feel a little less alien, a little more like home. And let's not forget the scientific potential. Studying lunar water could provide new insights into the moon's geology and history, and perhaps even the origins of water on Earth. It's an incredible opportunity for scientific discovery. Of course, there are challenges. Extracting and purifying lunar water will require new technologies and significant resources, but the potential rewards are immense. It's an exciting time for lunar exploration, a time of discovery and possibility. As we continue to explore the moon, one thing is certain: the discovery of lunar water has forever changed our view of our closest celestial